All right. We are recording. And let's see, I had myself pinned, right? Yeah. Okay. So while we wait, I will direct your attention to the plan that I had fun making in the background.
Can you like flip that because it's like backwards?
It's mirrored, yeah.
Oh, it's mirrored.
Yeah.
So, um, okay, how's that? Is that
Uh,
better?
Still
Hasn't
see it.
changed.
No, no.
Interesting. So, because I'm checking it to mirror,
Mm-hmm.
and for my last class, it like totally worked, or no one told me. Anyway, I'll see if I can figure it out. Maybe I will not follow this plan. So I just want to start with homework questions, and if we have additional time, we can do some 16.3 examples. I did post some additional examples, and we'll just do like a nice neutral background. And then you have homework due tonight. 15.8 through 16.2 is due to the Dropbox tonight. And 16.4 is what you should watch for Monday. And there are no videos yet. That'll be my task later today, probably tomorrow. I'll get those 16.4 videos. 16.4 is kind of like, you know, double integrals weren't enough, so we did polar integrals, and then that's not enough, so let's do triple integrals, and that's what 16.4 is. And actually, it's not that bad. Once you do double integrals, it's not that bad to add one more. So we'll do that tomorrow. Let's see here. I'm getting dinged, people coming in. Let me get my chat window up in case there are any comments there. Okay, so let's start with homework. Let me get in here. I have bunch of windows open. Where is the homework? It is here. Okay, let me share my screen. I'm going to focus on homework here from, let's see, I have, oh, this is 16.3. I don't want that up. Focus on 16.1 and 16.2 because I feel like we have already dealt with 15.8. We talked about that last week. And so let me get up 16.1 and 16.2. Did anyone have any questions? Since it's kind of tedious to flip back and forth here to open one document and then open the other one. Does anyone have any questions from 16.1? We'll start there. Double integrals over rectangular regions. Do you have any specific questions that you would like to ask from 16.1? See if I can get back up. Silence. Maybe I can open up while we're waiting 16.2 as well. Did anyone have any 16.2 questions?
Yeah, number 54, I just kind of had like no clue where to start.
Okay, let's take a look. 54. Oh, didn't we? Dude, we did this. We did this one.
Okay, I'll look at the other video then.
Yep, and so let me just quickly, because I've got it here. Yep, there it is. Evidence, proof. The key on these that we talked about, no worries. The key we talked about was to draw the sketch. And it's just kind of weird to do the 0 less than or equal to square root of x less than or equal to y. And so what we did is we kind of just looked at that inequality over to the side and said, well, that's the same as saying either y is greater than or equal to the square root of x, so it's above the square root of x, or if you square both sides, x is less than or equal to y squared, so it's left of the parabola. And so that gives you the region, and then you just decide, okay, do I want to do vertical or horizontal? And then am I going to add up y's first and then add up the x's, or am I going to add up the x's first and then add up the y's? And so, yeah, you can watch that video. I should, boy, it would be nice. I don't know if I have time for that. It'd be nice for me to do in the descriptions of the videos, say, hey, we talked about number 54 at 10 minutes and 20 seconds. So you can like click right on it. I shouldn't have mentioned that. I shouldn't have mentioned that that's possible. but, but yeah, go on the replay and you'll find it. We talked about that one. You should be good. Yeah, no worries. Any other questions from 16.1 or 16.2? I have them both up here. Any other requests? Okay. Just pop in the chat or unmute yourself if you want to make a comment or have any additional questions. I take that as a good sign because I know you've been working. You know it's due tonight, so I'm assuming you've at least looked through it. We're in Calc 3. Nobody waits till the night it's due to start. You might wait to finish, but nobody waits till the night it's due to start. So I will say if you have questions later today, your best bet is the Discord chat and like posting a picture of your work so your classmates can help. You know, my work hours are not from 8 a.m. until midnight, even though I'm at home and I'll get an alert when Discord pops up. I might not be able to comment on it. So, but that, you know, if you're all on there or if, you know, somebody else is on there, they might be able to help you. So what I'm going to do next then, since there are no additional questions, is on the homepage, I just linked to, I put some extra examples. So if you want to click on the 16.3 extra examples and kind of follow along, or I'm going to bring those up now in my OneNote here. And so I'm just going to do that, just do that and work through some extra examples there in 16.3. So without further ado, let's take a look at these and we're going to, oh, that's right. I forgot the instructions for this one. I forgot to copy the instructions. So I just copied some problems from the homework. The first one here is supposed to find the volume of the solid bounded by the surface and the XY plane, okay? So we have a surface and we're trying to find the volume of the solid where this is like the top boundary. And then we're gonna find the volume of the, between that and the plane. We kind of need to know where it intersects the plane to know what region we're integrating over. So how would we do that, I guess? How would we find where that intersects the XY plane?
Is that equal to 0?
Sure, right, do like a trace. Sorry, I'm getting like alerts when people are trying to get in. Oh, no, that was somebody leaving, I guess. All right, so 20 over 1 plus x squared plus y squared minus 2 equals 0. That seems a little weird, but hopefully we'll get something that we know how to do here. I'm going to add 2. Maybe just multiply by the 1 plus x squared plus y squared. Oh, this is going to work out nice. Divide by 2. And we get x squared plus y squared is equal to 9. Just a second, I got to close my office door. Okay, so that's where it intersects the XY plane. And so I think what we are assuming here is that the region is above, or the region is underneath the surface, and it intersects, oops, not 9, radius 3. And so the region we are integrating over is the circle radius 3 centered at the origin. I will say it's not uncommon for me to give a question like this on an exam and just say find the volume and not tell you whether to use rectangular or polar coordinates. And so what's the dead giveaway that polar coordinates are going to be a good choice here?
It's a circle.
It's a circle, right? So that's a dead giveaway that polar coordinates are going to be the way to go. Okay, so let's see here. volume will be, we're going to have a double integral over the region, and then the function 20. Boy, I hope this simplifies nicely. Yikes. We can have dy. We'll just call it d. We'll just call it dA. Okay. Actually, yeah, this should be good. All right. So we said we chose polar, and we know x is equal to r cosine theta and y is equal to r sine theta in general. This becomes then 20 over 1 plus r squared cosine squared theta plus r squared sine squared theta minus 2. And then what is the dA in polar coordinates? That's important.
RDR d theta.
That's correct. R dr d theta. Okay, and then dr, why don't you take 20 seconds or so and see if you can fill in the bounds. What are the bounds for r and what are the bounds for theta? Anybody want to share? What do you think maybe for r? What do we think for r?
0 to, or yeah, 0 to 3.
Yep, 0 to 3. And then theta is nice here because it goes all the way around. So theta will just be 0 to 2 pi. It isn't always, but it is on this one. So that's our integral. Any questions on the setup of the integral itself?
Yeah. Is it not -3 to 3 because like a radius can't be negative?
That's a good question. If you did -3 to 3, let me actually, I should do that in like a different color. If you did, just imagining a little slice here, if you did -3 to 3 and then went 0 to 2 pi, you'd like double up some of it. So usually in this context, we treat r as positive, and then we sweep out just that positive side and sweep that out as we go around. So I think you could do it from -3 to 3. I'd have to think more about that, because if it's negative, I think it has to go back. I think it has to be positive if we look at the derivation of the strategy, where the r was the radius of the circle. And so I think the way we derived it, the r has to be positive, now that I think about it. Yeah. Yep. So you want the r to be positive. Yeah, that sounds right. That's good. Any other questions on just the setup so far? Okay. Did not leave nearly enough workspace, or I took too much workspace up with other stuff. I don't know. Let's see, 0 to 2 pi, integral 0 to 3. If you'll notice in the denominator, there's an r squared. You factor it out. There's a cosine squared plus sine squared. That's 1. So this just becomes 1 plus r squared. And I'm actually going to distribute the r. And so you get 20r in the numerator, then minus 2r dr d theta. Almost feel like we need to do those separately. Maybe we could do, can we do u equals 1 plus r squared. Du is 2r dr. So we have 20r dr over 1 plus r squared. So will that be 10 du over u? Does that look okay? I think that looks good. I'm just going to do that and go by. The other one's obviously just r squared, the 2r, so not worried about that. That looks like 10 natural log absolute value of u. Okay, so I think we're good here. I learned later, not I learned, but I planned ahead better for the later examples. I gave a whole page of workspace, so it was not good planning for this one. 0 to 2 pi, and then we'll have 10 natural log absolute value of 1 plus r squared minus r squared from 0 to 3, and that's all d theta. Okay, 0 to 2 pi, and then evaluating at 3, 10 natural log of 10 minus 9 minus, oh, it actually does become 0. You got to be careful just assuming it's always going to be 0 here. Whoops. But when you plug in 0 for r squared, you just get natural log of 1, which is also 0. So, yeah. So it looks like we're just integrating a constant, 10 natural log of 10 minus 9 d theta. And so that's going to be 10 natural log of 10 minus 9 theta from 0 to 2 pi, which will just be all of that 10 natural log of 10 minus 9 times 2 pi. And I can cheat here. I have the answers. I haven't looked before, but I just checked and we're good. That's good. It's a good sign. Okay, so we did go kind of quick there. Is there any part of that you want me to revisit? You can type or just unmute yourself. Any questions on any part of that? Okay, I'm not seeing any. Let's try the next one then. So this one, the region is giving to us. It's saying that r is between 1 and 2, and theta is just between 0 and pi. Why don't you draw that? See if you can draw that region. You don't even need to draw the region here. You could just do the integral, but I do think it's valuable practice. So see if you can draw that. Theta is from 0 to pi, and r is between 1 and 2. So anybody have a good description for what this looks like?
Like a half washer?
Sure. Yep. Sounds like a good way to describe it. Radius from 1 to 2, but only from 0 to pi for theta. Yep. Nice. So that's what we're integrating over. Let's see. Volume will be double integral. And then here, what I mean is you didn't really need to draw it. You could just fill in 0 to pi and 1 to 2. And dA is r dr d theta over 1 plus, and then you just got to make sure you substitute in r cosine theta and r sine theta. You will see, by the way, a lot of these x squared plus y squareds just become r squared. In fact, that's actually, that would have been better than just plugging it in. x squared plus y squared is always r squared. That's the relationship between the two. And so we can just replace x squared plus y squared with r squared as part of our conversion. All right. Oh, this is actually like easier than the last one, because we could just do another. It's the same u sub. U equals 1 plus r squared du equals 2r dr, except we don't have a 2 this time, so we'll say 1/2 du equals r dr. And so the integral of r dr over 1 plus r squared becomes 1/2 du over u, so that's 1/2 natural log absolute value of u. Same idea, just slightly different constants. So I have 0 to pi, and then 1/2 natural log absolute value of 1 plus r squared. I guess we don't really need the absolute value there because it can't be negative, d theta. Can like hear like kids laughing in the background? Yeah, it's mine, okay. I wasn't sure if somebody was on mic and there were kids laughing in the background, or somebody was unmuted. No, it's on my end. Hopefully it doesn't get so loud that you can hear them. Let's see, 1/2 natural log of 5 minus 1/2 natural log of 2 d theta. Or maybe we could put the 1/2 in front. Maybe that makes more sense. Like that. You can put the 1/2 with each one or put it out in front. Does anyone remember their properties of logs? How to write that?
Wouldn't that be natural log of 5 over 2?
Yeah. And you could even be even fancier if you wanted to and do the 1/2, and you could even say integral from 0 to pi natural log of the square root of 5/2. It doesn't matter, whatever. It's not a big deal. And then we're integrating with respect to theta. Again, this is just a constant. We're going from 0 to pi, so it's just going to be pi times the natural log of the square root of 5/2. The 0 to whatever for theta is you just end up multiplying by the upper limit because you're subtracting the 0. Okay, let me zoom out here. Any questions at all about that second example? Okay, not seeing any. I have 2 more here. I tried to pick some later ones and be a little bit harder. Try to stretch us a little bit, make sure we're not just doing simple ones in class. Then you get to the homework, you're like, dear Lord, this is way too hard. So we have 2 paraboloids. One is upward facing one. That's the bottom, z equals x squared plus y squared. And then one is a downward facing one. You can see the minus on the x squared and the y squared. That's the top one here. And it's been shifted up 2. So you're basically looking at parabolas that one's downward facing, one's upward facing, and then you're looking at the volume between them. So I don't know, you tell me, what's the first thing that we really need to figure out if we're going to do this double integral? If you're going to do a double integral,
The region.
yeah, that I agree with Michael. That's my general sentiment is I should figure out what region I'm integrating over. I guess you could figure out what function it is I'm going to integrate, but I like to figure out the region I'm integrating over. So I feel like we did this last time of something similar to this. We're not given a region here. We just want all of the parts where there's something between the two. So does anybody else remember how we found that, how we figured that region out?
Set one of the functions equal to 0.
Close. That will find out where they intersect with the xy plane. So we did that on the first example, because we were looking at, oh, I don't have the instructions here, but we were looking at finding the volume between that function and the plane. So it's not quite that same here.
Should we set them equal to each other?
That's right, Max. So here you're finding where between them, so you're really looking for this boundary right here.
Mm,
And you can say that's Z1 equals Z2 right on that boundary. And so then we'll just kind of say, well, where do they intersect? What X and Y values is that? And then project that down to the XY plane. So 2 minus X squared minus Y squared equals X squared plus Y squared. Let's see here. Maybe add X squared and Y squared. Oh, this is too convenient. You add X squared and Y squared, you get 2X squared plus 2Y squared. You divide by 2, you get X squared plus Y squared equals 1. That's convenient. So a nice circle radius 1. There's our region R. Nice. Okay, so it looks like it's pretty simple, 0 to 2 pi again, and then 0 to 1 for the radius. We're going to have some function here. We got to think about that. And then there's an r dr d theta. That's the dA when we're in polar coordinates. So then the question is, I feel like we did one like this too, where it was the volume between two surfaces. And I think maybe it was Rudy who related it to Calc 2, like area between two curves. And it's the same idea.
I was saying top minus bottom.
Yep. So that's exactly what we're going to do here. Yep. So 2 minus X squared minus Y squared minus X squared plus Y squared. So top minus bottom is exactly it here too. Let me see that. Try to zoom in a little bit, make it a little bit bigger for you. Okay, now we're just going to clean this up a little bit. 2, and then X squared minus 2X squared, and then minus Y squared minus another Y squared, so minus 2Y squared. Oh, you know what? That was not a good idea. Well, that's fine. We just have to fix this here.
I have a question.
Yeah.
So I see that you wrote your integrand in terms of x's and y's, but I see that you're giving respect to r and theta. Is that like sort of slack or like improper?
I would say that it's like, I can't go any further. I can't integrate it right now.
Okay.
Right? Because I'm integrating with respect to r, and so I have a function of x and y. So for me, it's kind of like a substitution where you can have u's and x's in there at some point together, but eventually you have to have all u's. And so that's to me what this is like. Well, you can have x and y and r and theta in there in your setup, but eventually you better just have r's and thetas.
Okay.
Yeah, so that's a good question. So to me, it's not that this is incorrect. Like these equal signs here that I've written, they are all true. But I'm not going to actually be able to do the integral until I get it in terms of either all x's and y's or all r's and thetas.
Okay. Yeah, I'm just wondering that for like a test. Let's say if we write something like that.
Nope, this is totally fine.
Okay.
Yep,
Perfect.
This is totally fine. So to that point though, somehow I got to figure out how to get those x's and y's in terms of r's and thetas. There's an easy way and a hard way. Any ideas about the easy way? I don't want to do the hard way. It's not that hard, but.
X equals r cosine theta, so, and then y equals r sine theta.
So that will always work. That's the hard way. But that will work. That will definitely work. But there is a faster way.
You could factor out a 2 from the x squared, y squared, and then make x squared. Oh, wait.
Yeah, you're right. Keep
that's
going.
right. And then you could plug in r, right?
Right, because you factor out a -2, You're
Yeah.
left
Okay.
with x squared plus y squared. And x squared plus y squared is r squared. So Rudy's not wrong. You get to exactly the same thing. It's actually not much worse. But looking for x squareds plus y squareds, like looking for that, is definitely going to make your life easier. Don't forget your Calc 1 integrals now. That inside one, you can't integrate them separately. Just distribute the r into there. So distribute the r, we'll get 2r minus 2r cubed. This is pretty easy integral from now. So r squared minus 1/2 r to the 4th from 0 to 1 d theta. Looks like just 1 minus 1/2. Oh, geez. This is when you almost worry, like, is this too simple? Did I do something wrong? 1/2 theta from 0 to 2 pi. And so after all of that, that's crazy. The volume between those two parabolas, the paraboloids, I should say. So you have one like downward facing paraboloid and then another one that's upward facing. You get kind of like an egg. That's appropriate. And then the volume between them is pi. Who knew? Hey, let me zoom back out. Any questions on this example? I don't think I can show the whole thing without zooming too far out. I think that's too far. So any questions on the integration there or setup from that? I think this is the third one we were doing here. Awesome. Okay, and I just have one more, and then we'll call it a day. This one I tried to mix up some difficulty here. This one looked, oh, that last one looked harder than it really was too. So maybe this one won't be that bad. There's a lot going on here. So we have, in addition to the volume between two surfaces, which we have this downward, or no, it's not a paraboloid. It is, yeah, it's a hyperbolic, right? It's a hyperbolic paraboloid. So we're going to go underneath that, and then above the z equals x squared plus 3y squared, which is like elliptical paraboloid. But then we're going to go outside. So it's like a core drilled out of the middle of it. So it's hollow in the middle. So there's an additional layer of difficulty because we drilled out the middle basically. Oof. All right, what was the first thing we need to figure out?
The region.
The region. Okay. Well, I do know for the region, we can get us started. If we're outside the cylinder, it means the circle radius 1, we are outside of that. So there's a hole in the middle. So x squared plus y squared equal 1. We're outside of that. Don't shade inside that. So it's outside of that is the region we're integrating over. I wish this was a 3D model and I could just drag it down. Ooh, I wonder. No. Some of the textbook stuff is interactive, but not the homework questions. But they do have some examples that are interactive. It's kind of cool. Okay, I think we know what to do. We need to find this red line. Can't remember who said it last time. I feel like it was Max. Is that you, Max, last time?
Yeah. You want me to say it again?
Yeah, go ahead.
Okay, so you're just going to set each of the paraboloids equal to each other.
That's correct. We're going to find out where those two paraboloids intersect, and so that means we set them equal to each other. That's the red curve where they intersect. So that's going to be our outer boundary. We have our inner boundary is the little circle, that's the cylinder that's being cored out of this, and then the outer boundary, think of like an apple corer, right? The middle is just a little cylinder. So that's being taken out, and then the outer is going to be maybe a circle again. I don't know, maybe not. Let's see. Yeah. Oh yeah. This all like works out so nicely. It looks like this crazy region, but watch this. Add x squared. So you get 2x squared. Subtract y squared. You get 2y squared. Divide by 2. You get x squared plus y squared equals 4. How convenient. So unlike that one example where we had a half washer, now we have the full washer. Or if you prefer, frosted donuts, which I bought a whole huge box at Jewel for $5 because breakfast items were on the grocery list. So I'm buying in bulk.
You're taking our donut points and giving them to your family.
Giving them to my children, yes. I mean, it even looks like a frosted donut. Oh, that's just mean. Okay. That would be hard to do in rectangular coordinates. You'd have to integrate from one half circle to the other half circle, and then you'd have to do that on the bottom also. But in polar coordinates, that is a really easy integral to set up. Why don't you do that? Don't worry about the integrand right now if you want to, but why don't you set up the bounds? Integrating over the region, some function, and then dA. So the region is actually pretty simple in polar coordinates. And I know it's a little harder to volunteer in this environment, but I'd love to hear from somebody new. So I don't know if Daniel or Rose or Lisette, Kyle, Michael Grounder, if we want to, do any of you have an idea of what the bounds would be this time?
For the dr bounds, would it be from 1 to 2, and for the d theta 0 to 2 pi?
Yeah, nice, Lisette. Yeah, very good. So it's like this complicated region, but not in polar coordinates, and that's the beauty of polar coordinates. If you have something circular, that's a dead giveaway that you're going to use those, much easier to set up. And then our integrand is going to be similar to last time. We have the top function, negative x squared plus y squared plus 8. I didn't, maybe I left myself enough space, minus the bottom one, x squared plus 3y squared. And then again, to Max's point, I've got x's and y's in here. That's no good. We need to clean that up. And so let's go ahead and do that. 0 to 2 pi, integral from 1 to 2. 8 minus 2x squared minus 2y squared. It's just like last time. Can I just write it as 8 minus 2r squared? Does everybody see what's going to happen? You're going to take out a negative 2, x squared plus y squared, and x squared plus y squared is r squared. I almost integrated right now. Almost forgot to distribute the r. Let's do that first. 8r minus 2r cubed. That looks better. Easy enough. 4r squared minus 1/2 r to the 4th d theta. Oh, sorry, from 1 to 2. Ooh, we actually have to evaluate both endpoints this time. That hasn't happened yet. Integral from 0 to pi. 4 times 2 squared will be 16 minus 2 to the 4th is 16. Half of that is 8 minus, and then putting in 1, 4 minus 1/2. Whoa, sorry. Oh, it's almost 3 o'clock in the afternoon. Can we do that in my head? 8 minus 4 is 4, but then plus 1/2, right? So 9/2. Maybe. Just stop me if you see something here. I think it's pretty good, but. So it looks like 9/2 theta from 0 to 2 pi, and that's 9/2 times 2 pi, and so we get 9 pi for that volume. It's interesting how it like periodically shuffles you and like moves people around. Does it do that for you too? Or do you just only see me? I don't know. What does it look like for you?
I mean, I see you and like a couple other people, but it switches from time to time.
Gotcha. Interesting.
Typically switches to whoever's talking.
Sure, that makes sense. Yeah, that makes sense. I think I can turn that off and I can like pin myself. Well, I am pinned, so I'm always on top, and then it might show whoever's talking to. Yeah, that makes sense. Cool. Any questions on that last one? I'm going to go up to the setup here. I think that was the harder part. So any questions at all on that last example?
Yeah,
All right.
I do.
Oh yeah, go ahead, Michael.
So I'm a little confused about like why we used the negative x squared plus y squared plus 8 as the top if it's like in the negative y direct, you know what I mean? Because you do top minus the bottom, right?
You're thinking the key is that it's literally, so it's a z. These are z values. And so it's not in the xy plane, it's vertically. So it's literally the top function vertically minus the bottom function vertically. So vertical is the key there.
I got it.
Cool. Any other questions? Okay. So for tonight, we're kind of this delay like we usually would do. We wouldn't have homework due that night for the stuff we're working on Thursday. So it's through 16.2 for tonight. And then I'll have some videos for 16.4 for you to watch for Monday. And Monday we can take homework questions on 16.3 and 16.4. And then we'll do some additional examples if we have time on 16.4, some triple integrals. So that's it. One thing I like to say now, I know you're working hard, you're at home, and if you have time, try to find some time for yourself to get some fresh air, get outside, do some fun stuff, stay active, get up and walk around if you can, don't just sit there and feel like, oh, I'm at home, I need to be working all the time, and, do some fun stuff too. So I am learning how not to suck at Fortnite, which is not relevant for you because you are older than 11. But my children have fun. They're 8 and 11, so we're having fun doing that. So find some fun stuff to do to keep yourself sane. All right, everybody, I'll post a recording if you missed this, the beginning of this. Yeah, homework's due tonight. All right, I'm going to end the meeting. Take care, everybody.